Welcome to the Pioneer Plastics Energy Factory. In this video I'm going to give you an overrun quickly of the basics of a solar system, the different renewable technologies we use for heating, and then the benefits of the tank. The solar thermal storage tanks was designed at industrial large-scale applications and to be integrated with all renewable technologies like solar flat plate, solar evacuated tubes and heat pumps. Let's just start with the mechanics of a solar system. In essence, we've got two ways of introducing hot water into the tank: thermosiphon or pumped. These systems incorporate both. Thermosiphon technology brings in the natural flow of hot water where you've got dense cold water becoming less dense as it heats up and rises with the temperature difference. The basic mechanics of thermosiphon is always that the tank is 300 millimeters above the panel, exactly to what you're seeing here. So we've got cold water out, coming into the bottom of the tunnels. As it heats up the hot water, it goes back up into the tank and you've got that natural flow of hot water. And inside the tank, those pipes are connected at different heights. So we're withdrawing the cold water at the bottom of the tank and reintroducing the hot water at a higher level. Pump system means typically where your tank is at a different level of the panels, typically where your panels might be up on a roof and your tank down in the building, where you then incorporate a pump to circulate the temperature within that system. The tanks is a specially formulated thick wall polyethylene thermal storage tank. It has got the outer chromadeck finish with 100 millimeter thick polyester insulation. The system is designed to make the economics of a large-scale system more viable for industry. Let's just quickly spend a couple of seconds on the benefit of this tank compared to a conventional metal steel high-pressure boiler. Polyethylene as a raw material in essence cannot take pressure. So this tank is a low-pressure tank. So what we're doing is we're introducing the municipal water flow, which comes in at 3 to 4 bar, with a float valve. That float valve takes the pressure out of the water and it literally introduces the cold water at a non-pressurized level into the tank. That means that there's no pressure in the systems as well, and you've got a nice easy heating of the tank. But the hot water withdrawal, where it's introduced back into the factory or into the building, is then pressurized with a pressurized pump. So we would have an inflow of a high pressure 3 to 4 bar. We would have an outflow of 3 to 4 bar, which can be set at the pump, but the system itself is low pressure, which gives you a lot longer expected life within the solar system. Very important, in other words, low pressure tank, but it's a high pressure supply. Your conventional boilers being a metal tank, which is either lined or treated, has got a life expectancy of anything between 4 to 6 years. It is a known fact in the industry that a polyethylene tank can last 15 to 20 years plus. So because there's no metal parts in the inner tank, the life expectancy of this tank is enormous. So as a viable investment in a large-scale system, the solar thermal storage tank from Pioneer Plastics Energy would give you a lot longer return on investment and obviously the sustainability of the tank. These tanks run comfortably at a temperature of 80 to 90 degrees with the construction and the formulation we've done, so it's very effective at storing that thermal energy for you. We can, however, introduce for you an electrical 3-phase element backup, which can give you electrical heating for your peak periods, like in an evening shower or an early morning usage of water. In terms of thermosiphon, we are at the moment doing 1,000 litre, a 1,600 litre, 2,500 litre and a 5,000 litre tank. As soon as you start getting into the 2,500 litre ranges, as you can see the tank in the background, all that we do is we just bring the hot water at a higher level into the tank. So that tank can be mounted flat on the roof and it can still act as a thermosiphon system. The same with the 5,000 litre, which is a similar height. I'm going to give you an example of two systems currently installed. There's a technical high school in Rustenburg. We've got a 1,000 litre system similar to this pumped, which is used for the kitchens. And we've got a 2,500 litre also pumped, which is similar to the green tank at the back, that size for the school dormitories. Let's look at the control of the system and how we're doing the mechanics and the flow of the solar panels into the tank. First of all, I think it's important to mention the pipe work. For the pipe work, we're using a very high quality SABS approved Ginder pipe system. It's a flexible pipe, so you can easily bend it with the contours of the tank, and it's a crimped fitting, which gives you the quality and the reliability of the shrinkage of the connections. As I mentioned before, cold water is introduced at the bottom of the tank. It goes up to the float valve. This is our solar panel cold water out. Here you can see the little pressurized pump. This one in particular is a 12 volt. You also get them in a bigger 220 volt pump as well to give you the higher flow. Obviously that's with more panels and a larger scale tank. And that's just our hot water out, where we've got a little flow meter for our controls and measurement at the factory. So all in summary, the Ginder pipe, easy connection, all coming out at the bottom of the tank. For our controller, this specific unit is done with a Giezerwise Max. It's a South African manufactured system. What we've got is our little control panel. This will be either in your building or your kitchen. The solar system or the intelligent controller has got a probe at the top of the tank that picks up the temperature differential between the tank and the solar panel. So as the panel heats up 5 degrees above the temperature of the tank, it'll give power and a signal to the pump to start pumping. With this controller, the way that it works, you can program 4 timing sequences. So if we had the element backup, you could get the system and program it to say by 3 o'clock in the afternoon, check the temperature of the tank. Let's say you want it at 60 degrees. If the panels have not done the job of heating it effectively to 60 degrees, the system will give a signal to the electrical element via a solenoid, and it'll heat the tank for you electrically. This pump in particular is a 12 volt pump. It's designed for the 1000 liter system, giving us quite an effective flow. You also get a 220 volt, much larger pump, which we then obviously recommend for your larger systems. But again, that is system specific and should be specified by your solar panel or heat pump company in terms of the flows that they recommend you do. But our controller, just with the interaction of a relay, can power any size pump. It's just a question of sending a signal to the pump. So that's very important. You need to talk to the solar company to get the right size of pump, but it incorporates within the system. But in essence, this is what we can offer you. Number one, it's very cost effective in relation to your normal conventional metal boilers. Number two, the life expectancy of this tank is superb, 15 to 20 years plus. And thirdly, the thermal insulation is designed so that you've got a minimal 3 to 4 degrees heat loss over the duration of the evening, so that you can optimize all that solar thermal energy that's harnessed during the day. So we hope to hear from you soon. Place your orders, we can customize it, we can even color code. So contact us, color schemes, connections, and we'll take your orders from there. Thank you very much.